Hello, this is Mr. Krieger, and today we're going to do a lesson, or I want to do this lesson on simulation with you. And the reason why I'm going to do this one on video is because it's a little bit confusing, but this way you get to rewatch the video as often as you need to really understand this process. So just let me explain to you what we mean by a simulation. You know, when we're trying to figure out the probability of something, some events are easily known. Like, for example, if we take a coin, typically on most coins, we know that if we flip it, there's a 50% chance that it will come up on heads, and there's a 50% chance that it will come up on tails. But let's say my coin is a weighted coin, and it's not a fair coin. And let's say the suspicion is that, like, it comes up about a third of the time on heads, and 2/3 of the time on tails. But I'm not sure about that, and I just want to check it. So what would I do? Because there's no other way for me to check. Well, why don't I flip the coin over and over again, let's say 1,000 times, and count the number of heads and count the number of tails. And let's say after 1,000 times, I got, let's say, 312 heads, and the rest were tails, so 688, okay? Well, in that case, it kind of demonstrates that the percentage is about a 33% rate. We don't know the exact amount, but it gives us a rough estimate, somewhere around 32 or 33% or 31%. And that would be a simulation in order to test what the probability of this coin, this weighted coin, this biased coin, winding up heads. And if I wanted to check it with more accuracy, I can keep flipping this coin more and more. I can do it 10,000 times. It's not an efficient way of figuring it out, but it's definitely a way for me to figure out the approximate percentage of the time this weighted coin, this biased coin, would come up heads, and what percentage of the time it would come up tails, and therefore we can compute the probability that way. Well, that's the whole idea of simulation, but we're going to do a more complex simulation today in this lesson. So let me show you, and this is really like the heart of the course and what we'll be covering for the entire year, at least especially toward the later part of the year. And in order to illustrate this, this idea of simulation, we're going to use this example called distracted driving. And you have this document in your packet or on your OneNote, and we will go through it here, and we'll try to make some sense of it, okay? So here is the question. Are drivers more distracted when using a cell phone than when talking to a passenger in the car? Researchers wanted to find out, so they designed an experiment. Here are the details, okay? So keep in mind, we are testing to see if cell phones are a greater distraction than just the normal things that would happen in your car with a passenger, okay? And that's the idea that the cell phones cause accidents or, you know, other safety issues, and we want to check that out. So this is the experiment that these researchers ran, and let's see what the results of this experiment were. Okay, in a study involving 48 people, so they took 48 volunteers, 24 people were randomly assigned to drive in a driving simulator while using a cell phone. The remaining 24 were assigned to drive in the same simulator while talking to a passenger that was also in the simulator. Part of the driving simulation for both groups involved asking drivers to exit the freeway at a particular exit. In the study, 7 of the 24 cell phone users missed the exit, while 2 of the 24 talking to the passenger missed the exit, okay? By the way, this is an actual AP exam question, okay? So just so you understand what's happening here, this is not necessarily proof of anything, but it does seem to be that the cell phone is causing some kind of distraction because of the group of people they had in the simulator talking on the cell phone, 7 of the 24 missed the exits. And of the 24, the other group of 24 that were assigned to be in the simulator with a passenger, only 2 of them missed the exits. Now you might say, oh, this is conclusive evidence, but in statistics, we're going to take this further, and you'll see what we're going to do. So we're going to first summarize this data. This is a nice two-way table that we'll be learning about actually later in this unit. This side has, did they miss the exit, yes or no? The distraction here was cell phone or a passenger, okay? So for the cell phone users, how many people missed the exit? Well, we know that 7 people missed the exit from the cell phone group. And from the passenger group of that 24, only 2 people missed the exits. So how many people did not miss the exit? Well, we have to do 24 minus 7 for the cell phone group, and that's going to give us 17. So 17 people in the cell phone group didn't miss the exit. The cell phone clearly wasn't a distraction for them. And for the passenger group, there were 22 that didn't miss the exit. So again, this is a total of 24 people in the group of the cell phone people, and there's 24 people in the group with a passenger. So this is a total of our 48 people. Okay, so we can see, and these charts will show you like percentages, like you can see that the percentage of cell phone users is greater than, that missed the exit is greater than the percentage of passenger, the volunteers with passengers. Okay, so what we're going to do now is we're going to take a look at another table. So here, let's just take a look at percentages. From our cell phone group, there were 7 people who missed the exit out of 24. That was a proportion of 20.292 or 29.2%. For the passenger group, we know there were 2 people, and 2 out of 24 is 0.083, which is 8.3%. So look, this is like more than triple the amount of people who missed the exits in the cell phone group. But again, we're not saying that this is conclusive. We're going to take a look a little deeper, all right? So here's what we're going to do. Here's what our simulation is going to involve. And this simulation is more complex than our simulation with the coin and figuring out what the percentage of times it comes up head was. Here's what we're going to do. We are going to take the data we got from our experiment, and let's go back to that particular data. I'm going to take this data, and what we're going to do is this. We're going to say, well, let's say cell phones really aren't a distraction, and just by the luck of the draw, just like if you have a regular fair coin, it's possible to get 3 or 4 heads in a row. It's not too likely, but it's possible, and it happens sometimes, right? So maybe there was really no difference between these two. It's just that in this particular group of people, 7 people missed the exit who were talking on a cell phone, and 2, but let's say those 9 people who missed exits would have missed exits under any circumstances. Let's say they're generally not great drivers and they just happen to be split up in such a way that 7 of those people who would normally miss the exits happen to fall in the cell phone group, and those other 2 people who would normally miss exits happen to fall in the passenger group. So it looked like something was happening to the cell phone group, but really it was just that those 9 people always missed exits. So we're going to write that down. We're going to say, since 9 people missed exits, we will say they always would miss an exit. Those people were just people who are distracted in general, and it has nothing to do with the cell phone or the passenger, okay? So that's the idea. And we're going to simulate this by using a deck of cards. Now, how are we going to do this? Well, a deck of cards has 52 cards in it. What we're going to do is we're going to say, well, we had 48 volunteers in our experiment, but there are 52 cards, so I'm going to remove 4 cards. So I'm going to have 1 card for each person in the experiment. So I'll take out 4 cards, and let me take it out in some sort of way that will be easy for me to keep track of. Let me take out all the kings. So let me find the kings. I'm going to remove them. Okay, there's a king. So I'm going to find all 4 kings, remove all 4 kings. And after I've removed all 4 kings, now I have 48 cards. Now, each one of these cards is going to represent one of the people involved in the experiment. Now, the next thing we need to do is we need to take these 48 people and we need to designate some cards that are going to represent the 9 people who miss exits. So maybe the best thing to do is we need 9 cards that are going to be those people who just happen to always be distracted, no matter what, cell phone, no cell phone, they're just always going to be distracted. And we're going to designate those people using a certain group of cards, and let's pick something that's easy for us to remember. Why don't we pick the ace of hearts through the 9 of hearts. So basically, these 9 cards are going to represent people who always miss exits. And everybody else were going to be people who don't miss exits, right? And because a deck of cards is not really real people, it's just a deck of cards, and we know that decks of cards are just random things, right? You know, I pick a card, it's random what would come up, especially if I shuffle a deck. And this is what I'm going to do. I'm going to shuffle this deck really well. By the way, they say to get a deck to be thoroughly shuffled, you need to shuffle it 7 times, okay? So we're going to shuffle this deck 7 times, and that will be thoroughly shuffled. And remember, these are our 48 people. And remember, we have 9 people who generally always miss exits, no matter what, cell phone, no cell phone. And the rest of the people, the 39 leftover people, those are people who were very good drivers. They rarely would miss exits, you know, under any circumstances, okay? I lost my count, but let me do one more, and I'm sure we at least exceeded 7. Okay, so now, this is the next idea. In our experiment, we had 2 groups of 24. So I want to split this deck up into 2 groups, but you know what all I really want to do is count off the first 24 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And this is going to be the group that had the cell phones. And the rest of the cards, another 24 cards, those cards are going to be the group with the passengers. So this is just like our experiment. There were 24 people in the cell phone group and 24 people in the passenger group. And I'm going to just take a look at my cell phone group. And what I'm going to look for is I'm going to look for how many of people or how many cards in this deck with these are the cell phone people. How many were those people who miss exits? The ace of hearts through the 9 of hearts. So let's go take a look at them and let's count them. No. So we're just looking for ace through 9 of hearts. Oh, there's 1. There's 2. There's 3. That's not 1. That's ace through 9 of hearts. There's 4. Okay, so here's what we got. Let's double check it, 4 people out of 24 from our cell phone group missed an exit. So these are the people who always miss exits, right? So let's go back. I want to show you now. I'm gonna keep a table, because what I'm gonna do is I am going to take count. I just tried this one time, and I found that there were 4 people who missed the exit who were from the cell phone group. Now I can go and look at my other group, which is my passenger group, and see how many people in my passenger group missed exits. But I kind of know that because I know there were 9 people in total. There are 9 cards between ace of hearts and 9 of hearts. So I know there's going to be 5 in there to make up 9. So there were 5 people in the passenger group who actually also missed exits. This time it was 4 and 5, so it was different from the first time. The first time was the actual experiment. This time it's just a simulation. We're simulating. So remember what we did with the coin? When I wanted to see if this coin, if the percentage of the time it came up heads, in order for me to check that, I flipped this coin many times. 1,000 times would be a good start. And we got, what did I say, 312, let's say, heads and 688 tails, right? So it was about 30%, right? Okay, I just did this one time. Well, what if I do this many times? So here I have 10 times. Now, I'm not going to do this 10 times with you right now, but I am going to do it one more time. Let's see what happens if I do the same thing one more time. I'm going to shuffle the deck of cards thoroughly. Remember, 7 times gets you a truly shuffled deck. So that's 1, 2, 3, 4, 5, 6, and this will be 7. And now I'm going to split it into cell phone group and passenger group. So my first 24 cars are going to be my cell phone group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so these were my 24 volunteers that fell into the cell phone group. These people were going to use cell phones. And the rest of the people, the other 24 people out of the 48, fell into the group that had a passenger in the car with them. And we're now going to look for, from this group, how many of them are exit missers. That is ace of hearts through 9 of hearts, so let's count them up. Let's see how many we have. That's 1. I'll keep that on the side. That's 2. That's 3. That's 4. 4. All right, actually happened to be just coincidentally the same thing again. We got 4, and I'm going to go mark that down on my sheet. And I'll show you what we're going to do. So now, the second time I tried this, we got 4 and 5 again. Okay? Remember, in the original, there were 2 people who missed the exits, who were cell phone. 7 people missed the exits from the cell phone group, and 2 people missed the exit from the passenger group. Now, I did this experiment another 8 times on the side before I started the video, just to get, and I did it by a different kind of simulation. I didn't use the cards because that would have taken me a long time. And these are the results I got. I got 3, which makes this 6. I got 4, which makes this 5. I'm sorry, 4, which makes this 5. I got, I got a 5, which makes this 3. Am I doing that right? No, it makes this 4. I got a another 5, which makes this 4. I got a 6, which makes this 3. A 6, which makes this 3. A 5, which makes this 4. And a 6, which makes this 3. So again, we do it a lot of times. Now, normally I would do this experiment in class with all the students, and we break up into groups, and I'd have each group of students of 2, let's say, do this 10 times, and we would get lots and lots of data. So in a normal class, I would have, let's say, 7 or 8 groups of students do this 10 times, so we get like 70 or 80 data points. But here's the thing I wanted to show you. Remember in the original experiment, what happened was 7 people from the cell phone group missed the exits. It's like, oh, that was weird. Those people just possibly coincidentally missed exits 7 out of 24, whereas for the passenger group, only 2 missed. We never even got an instance where that many were missed. We never got an instance in our simulation, the 2 that you saw me do and the 8 that I did on my own. Never did it hit 7. We had a couple of 3 4s, a 3, a few 5s, a few 6s, right? Now, what we're going to do is, I'm going to show you, we're going to make a dot plot of this. So, there's a possibility of missing 0 exits, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are number of missed exits for the cell phone group. And here was our data. I'm going to make a thing called a dot plot to show you like basically a chart with what happened. We had 4 people miss. We had 4 people miss. We had, and this is all, we re-simulated this 10 times. So for one simulation, we had 4 people miss. The second simulation, we had 4. This third simulation, we had 3. The fourth simulation, we had 4. The fifth simulation, we had 5. The sixth simulation, we had 5. The seventh simulation, we had 6. The eighth simulation, we had 6. The ninth simulation, we had 5. And the 10th simulation, we had 6. So absolutely none of our trials showed 7 or more missed exits for those people who were talking on the cell phone. So what is this going to mean? It kind of indicates that missing 7 or more exits is kind of a rare event. And it probably wasn't based on any chance, like flipping a coin chance. It was probably based on the fact that the cell phone had something to do with being a distractor. What we did, let's go back and think about what we did. We just assumed, for the sake of doing this simulation, that all 9 people who missed exit from both groups, the 7 people from the cell phone group and the 2 people from the passenger group, we just assumed those people all missed exits under any circumstances, right? And then we said, well, since it didn't matter what the distraction was, 9 people are going to miss exits under any circumstances. If that's our assumption, just to start off with, by using our 48 cards and trying this over and over again, we want to see how many times we hit 7. Well, we didn't hit 7 even once. So our assumption seems to have been false. The assumption that these 9 people always miss exits, it seems like, at least based on this preliminary data, that the cell phone actually seemed to have a greater effect on being a distractor for drivers. Now, I want to show you this. This is a histogram. I hope you can see this. Let me check my phone. Yeah, this is a histogram of this simulation being done. Instead of 10 times like I had done, it was being done 1,000 times. It was 1,000 trials. And you see that the majority of the time, 4 and 5 exits were missed by the cell phone users. And then again, this is under the assumption that those 9 people always missed exits. And very few of the times was it 7 or more. See, it's as a percentage, it was only, if I remember correctly, it's about 6 or 7% of the time was it 7 or more. 7 or more exits that were missed. So our assumption, and what we were doing the assumption that we were doing this simulation under, was that these people were going to miss exits no matter what, whether they were cell phone users or not. But the data seems to suggest, and I'll give you a better understanding later in the course, but the data seems to suggest, well, 7 or more doesn't happen too frequently under that assumption. So maybe our assumption was false. What would be the alternative? Well, the alternative would be that, in fact, it wasn't that this was some sort of random thing. It was that the cell phone actually seems to have been a distractor. In other words, if it weren't, then we would expect this 7 and 8, especially the 7, to be a lot higher and happen a lot more of the time. But it doesn't happen a lot of the time, which seems to indicate that the simulation under our assumption is false, and therefore the alternative, that cell phones actually are a distraction that cause missed exits or possibly accidents, is more plausible. So that is how a simulation is done. And just so you know, the latter part of this course, the second half of this course, is based on examining data like this to determine whether or not something happened just by chance, or if something happened because of some sort of cause and effect. In this case, the cause was the cell phone being a distractor. So I hope this video helped you to understand this problem and also what simulations do.